Hello everyone. You might have heard a lot about feature store now these days. Several organizations are using feature stores. There is a lots of news coverage. Last year in 2021, a lots of companies got funding to build feature store. So there are new startups who are creating these creative ways to build the feature store to support machine learning as well as the prediction pipeline. Some of the existing companies such as DataBricks and Google have built their own feature store. Some large or very large companies, they are using these open source feature store such as Feast to fulfill their need of feature store. So you might be wondering what is feature store, and you have heard and you have read and you have watched lots of content about feature store. So to answer questions about feature store, its architecture, its overview, how it works, I thought it's best if I create an AI engineer view of feature store. It means every step when we are going to create the feature store, initialize it, use it, build features based on our input data, learn how to access the historical data versus the online features, how features are created, where features are stored, what is the backbone behind it. During my own understanding and learning about feature store, I find some of these technical details, they were not available, or they were only available to some of those engineers who have built the feature store. So I thought it's best that I could create a video talking more deep technical details and the real-time creation of various components when we are initializing, creating, and using a feature store. So hello everyone, my name is Avkash, and in this video I will go deep under the hood and show you how everything works under the hood. So this tutorial is specially created for you, so please enjoy this tutorial and let's get started. So what is a feature store? As defined here in front of you, you can see is that a feature store is an operational data system, and that is for managing and serving the features to the models when this model is deployed into production. So using a feature store, you can serve feature data to the model, whether you want to send this data, which is very high latency data, such as real-time records, or you can send those features, they are coming directly from an offline store, means the data is already stored, that could be stored after a sequential or batch processing, or it was done during the model training. So in general, or if we try to define feature store, you can think that the feature store just a simple storage system which extract the features as defined by the data scientist in any organization and provide those features for prediction as well as for training. There are several advantages of using feature store. Very first problem is that when you are deploying your model for prediction, it really need a consistent access to the data. And if you do not have a feature store built into, the preparation work for incoming data as needed for this model is very important. If you do not have feature store, most of the feature engineering work or the feature establishment work was done in the pipe, and that pipeline does not exist anymore after the training. So the new incoming data need exact same data processing that was done for the training. So the feature store solves that problem by storing all those features in a way is that when this new data comes, that online data is immediately sent to your model for prediction or for scoring. Feature store has built-in capabilities, so you can deploy these new features in production pipeline very quickly. One big use for feature store is the reusability of these features. So if you have vast data sets scattered across various teams and silos within an organization, using feature store, you could reuse these features which are extracted from a certain type of data, but those features can be applicable to wherever that data type is available across your data science teams and organization teams as well. One thing to One important thing to remember is that feature store does not do the feature engineering, or there is nothing automated in it in terms of creating features. A data scientist or the domain expert is needed in order to understand the data very well and then create those features. So the discovery of features, the validation of a feature, whether it's applicable or not, its validity in or its contribution to model training is really good or not, all those things are really not part of feature store. However, if there is an organization which want to build their own feature store, they could design and develop all those features. Here, when we are talking about in general, a feature store may not have those capability to start with, but that does not mean that you cannot add those capabilities on top of any open source or available feature store. Now we can look into that what or different kinds of feature stores are available. Google does have their own feature store and it is called the Vertex AI. If you are interested, please go ahead and review by yourself. If I get time, I will try to add my own video on Google Vertex AI feature store. DataBricks also has their own feature store, and that feature store is in public preview stage. And I do have one screenshot explain that what capabilities are in DataBricks feature store. First, they have open data and model format. And as you could see here left, the feature definitions means the feature definitions are created using the pandas or any popular language of your choice. Those features are created and they are stored into the feature tables. And for DataBricks, they are using the Delta Lake to store all those features into the SQL tables. It means those tables are easily accessible using SQL language and the SQL connectors, and then using any programming language which can connect with SQL over through SQL connectors. Once these features are stored, you can use those features for a variety of use cases. You can send those features for model training, and depending on your machine learning engine and your programming language of choice, you could build those models. Same features can also be sent to your model for scoring, where your model is deployed, and depending on wherever you would want, because the accessibility for these features are pure SQL based. If you would want to perform the batch scoring, you can read those features directly from these features table and perform the batch scoring. And if you would want to deploy whole batch scoring applications on using MLflow, which is supported by DataBricks, you can do directly that as well. So that's the DataBricks feature store. Tecton is the organization behind Feast, which is an open source feature store. So Feast stands for FEA-ST. So FEA for feature, ST for stores. It's a feature store and it's an open source project. And here you can understand the usability of feature store from data scientist perspective and from AI or ML engineer perspective. Here you can see that it's a data scientist job to search and discover features and define the features along with the transformation on those features. Finally, the feature store job is to store the data which is coming from either saved or historical data or the real-time data which is coming out from Kafka, Kinesis, or any real-time streaming framework which is supported through a connector. Feast takes that data, store it, transform it depending on the transformation set up by the data scientist, and then it serves those features depending on where they are needed. They could be needed for building machine learning model, or they could be needed for prediction. So same feature store reads the real time as well as the saved or stored data, apply the transformation as defined, and can deliver those features to machine learning pipeline or for prediction pipeline. And those pipelines mostly created by AI engineers or your ML engineers. So that's the role of feature store in any organization. Today, in this tutorial, we are going to take a look at Feast or open source feature store, which is driven by the organization Tecton. And here is, in a nutshell, they have defined the feature store. You can send your real-time as well as the stored or historical data directly to a feature store. Depending on what the features are selected and the transformation is added top of that, everything happens, means transformation happen. All those transformed data are stored at the feature store, and depending on whether you want to perform the machine learning training or you want to perform the scoring, whether it's online, offline, real time, or you want to do the batch, depending on what your needs are, those features are sent to your target requirement. Quite simple and very easy to understand. So here is the documentation and here is the Feast architecture overview. So we will walk through Feast architecture using a live example and digging into it. So very first, I would like to show that I do have few Jupyter notebooks created, and these Jupyter notebooks will help us to learn Feast feature store as an AI engineer perspective. First, I have Python 3.7 environment. Here I am just installing some of these packages which are needed for Feast feature store to work. Here I am installing the Feast, but in case you might see some problems with your Feast and you might need to install YAML, and here are some instructions for you to install it correctly. I already have everything updated here. I do not need this. I will be looking into the Feast. As you could see, I already have the latest Feast installed in my machine. Very first thing, you are going to initialize the Feast, and you are going to say that you would want to initialize the Feast project feature repo. Before we start, I would want to show you that the root of this project where Python is running is something like that. This is our present working directory where Feast starter is there, and as you could see here, there are only few files available. There are no directory, etc. So when you are going to initialize the Feast with a project name feature repo, the initialization is happening. As you see here, it's creating a new feature repo in this Feast starter folder name feature repo. So this is what we have requested to Feast, that please initialize the feature repo. If you see here, the feature repo folder is created, which was not there in our current working folder. So it means that we were already in feast starter location, and this feature repo is created. Let's look what is inside feature repo. Here you could see that we have a data folder created. There is some example.py and featurestore.yaml. So this init project was a sample project which is already part of feature store library feast. And if we look into what is inside data here, you can see, let me just show you here. To look into ls-l, first we are using the feast starter, then data, feature store. So we are here, so we need to go feature repo, sorry. And as you could see here, a new file driver stats.parquet is added, and that is for this example. Because we are creating an example feature store, that's why this data was already added during the initialization phase. Next, we have this feature store.yaml. So let's take a look. Here you could see that the feature store definition file says that create the project feature repo, and the registry for this feature repo is going to be stored into a folder called data, and the registry name will be registry.db. We have already seen in this data that there is no registry here as of now. Next, the provider for this feature store are the local, and the online store for this will also be created in the data folder, and its name will be online store.db. So this is the definition of our feature store YAML. So what is feature store definition? Let's come back to documentation. And here, if you look into feature repository, and here you could see that this is similar what we have seen. We have a feature store YAML file. We have example or the driver features.py, and we have data where the Parquet driver stats Parquet file is there. So now we have better understanding about how our repo folder look like. So let's try to understand the overview. So as you see that we have seen the registry.db, so there is a registry, and as you could see here that a registry store is needed for your features to be stored, and we need to look into this. Oh, sorry, here. So when we are interested to understand more about registry, currently the feast supports three options. Whether you could create registry on S3, you could create registry on local file system where feast is running, or you could use the Google Cloud services. So you need to define where the registry, feature registry will be created, and what registry is basically the catalog for all the feature definitions and the metadata associated with them. And there is a SDK available which can probe this registry and can give you information about those features and the metadata associated with that. Next, let's come back here. Now we can look into the feature repo example. Here this example is exactly the same which is driver features.py. It means that the example, basically the definition of features related with the data. Here, as you could see here, that there is some modules are imported here, and here is from feast, import entity, feature, feature view, file source, and value type. So now we need to understand what the entities are, what the feature is, and what the feature views are, and the file source, etc. Let's come back here and look into the concepts overview. A project is a collection of feature views, and the feature view is a collection of features, entity, and their data source. Look into the data source. As you could see here, data source could be any data which we are going to use as the source for features. And in your data source, you are going to have the timestamp, because it's mostly for time, where the data is changing as the time moves in newer or positive direction. You have entities, and there are the features related with those entities. So here you could see for the driver ID 1001 has done the 5 trips today, and the rating, cumulative rating for those 5 trips are 4.8. So this is a feature. So rating is a feature, and feature value is the value for that particular entity. So entity and feature, basically they have their own value. If each entity has its own feature value. Features could be one or more, and similar to entities as well. Here, now you can see that entity and entity key. So in this example, where the customer ID or the driver ID, they could be 2 separate keys. So when you are thinking entity with respect to a feature store, think about as a primary key in your database or in your tables. So depending on what input data source you have and the data you have, all the features where you are going to get detailed information through a combination of primary key, you can think them as the entity and define those values as the entity keys for that particular entity, or entity basically a column name as shown here in this. So driver, entity, and the keys are drivers, all the driver values. Here is the feature view. So for the entity, so here as you could see here, the feature view name is the driver activity and entities driver. So for the driver, we are seeing the driver activity, and depending on our data set, it shows that the trips today and the rating are the features which are associated with this driver entity, and this record is considered, or this whole information is be considered as a feature view name driver activity. Let's come back here. So we have seen that entity, feature, and feature view. So based on our input data source, so here is our input data source, driver stats.parquet, and in that data source, the driver hourly stats object will be created, and based on this object, the entities will be added, and based on those entities, the features will be created. So let's take a look into the data set also. So I have this Jupyter Notebook. As you could see here, this the place, and here, so feature repo. So we need to go feature repo. We need to go to data folder, and now we are in driver stat.parquet. We are using pandas, and now we are using the pandas, and the method is read parquet to read this driver stats parquet, and here is our data set. As you could see here, that timestamp is there, there are driver IDs, and there is the conversion rate, accuracy rate, average daily trips, and when this record was created. So this is the list of columns, and here is the data frame detail for you. So for this data set, if we look into the definition of features, it's a feature definition file. Here you could see that there is a column named event timestamp. This is the event timestamp, which will be used for time series data. Created timestamp column is a created, and here you could see that this is the created. So when the record was created, because that's how you will be able to understand when the record came into the existence. And after that, define an entity for the driver, and it's going to use the driver ID, and value type will be depending on what it is, and then description is the driver ID. And here, as you could see here, this driver ID will be used. So if we create an entity here, you can think of the driver ID features will be stored based on each ID. So if there are 200 record based on driver ID 1005, those features will be associated for driver record 1005. Now, once we understood the structure for our feature initialization content, make sure that we haven't applied, or we haven't created a feature store yet. We only initialize the configuration, and here we will learn more about that through these commands. So here are these commands available for us to use with feature store feast. Let's try to use this endpoint. And you will see here that when you say endpoints, it's a can't find feature store.yaml. And it means that we haven't initialized the repository correctly. Now we look into the feature repo, our feature starter. We are here. Okay. Now let's look into the feast endpoint. As you could see here, that when we call this endpoint, it was expecting a feature store.yaml to understand what could be information related with feature. Once we are inside this feature repo folder, now this feast can read feature store.yaml, and it gets some understanding of that. And it says that, okay, there is no active feature server. It means you get an idea that initialization is done, because in this case, it didn't even understood initialization part because it never see the feature store.yaml. But here it understood that, okay, I do see feature store YML, but the feature store is not ready yet. Let's look into the entities. And if there are any entities, and the result will be null. Means there is nothing at this point because feature store is not created yet. So let's look into this. And here what I am doing is that I'm just loading this example.py, and it's designed in a way that we could run this whole thing. As you could see here, we ran this whole code. Now you could see here that in the data folder, this registry.db is created. So previously we only had driver stats.parquet file. Now the registry.db is created. And if you look into the YML configuration here, you see here that registry is initialized now. The online store is not created yet, but the registry is initialized as of now. So that should give you an idea that, okay, at least we ran this example.py, which was the feature definition file, and then it created a registry. Now let's come back to a different Jupyter Notebook to connect with the same feature store. So here we are just importing the required modules. Feast is working here. Endpoint, again same thing. So I will just try to show that. Okay, now we are in the folder, where there is no active feature server. Here is the example .py, same thing. So now what I'm trying to do is that in the previous code, I have launched this whole code directly, and that it created the registry.db. So I just wanted to show you that the timing shows registry.db, that when we ran this thing, that time that registry was created. Now, here I'm running the same code, but rather than running all at once, I'm just trying to run that piece by piece. Here we have driver hourly stats, and if you look into that is a file source type, and then we are defining the entity, and if you look into this is a entity type, and here we are just defining the entity. And now if you try to look into the entity list, there is nothing, means it's not created yet. It's just the definitions all about here. Now if you are trying to run this code and we look into the driver stats view, so this is the driver stats view. So this is your feature view, and that is what really created. And if you look into this view and you try to say what the entities are, so entities are driver ID, input, this is the file source we have, and here are the features. So if you look into these three features are created: conversion rate, accuracy rate, and here is the average daily trips, and here these value types are. Okay, we have already seen this, and we have, this is a Python. So now whether we run this point, so whether you can run this whole thing or you can just use this Python example.py, and which will launch this whole example.py completely. So let's run this. Now, as you see here, still there is no server. Now what we do, we are going to do something called feast apply. And after that, you see here that the created entity, created feature view, and created the sqlite table feature repo driver hourly stats. So depending on your feature driver hourly stat, there is a table created here, and that belong to your feature driver hourly stats. Okay, let's look into the data, and now you see here that online store.db is created, which is holding your this table, SQL table. So that is also created, and you see here this registry DB is also created when we have launched this command here. So that's just created. So when you said apply, so when you processed feast apply, that's what the time when your feature store was instantiated correctly. Here you see. So you use the feast SDK and feast apply, and what it did is actually instantiated the registry as well as the online store. So now we have apply this feast command, so that features are created and the feature table is also created. And because our settings are in the YML to use the local store, that's why it is, I think it's here, local, that's why it's using the data. If you would want to set up this thing in some other place, you could say that you want to use somewhere else, then this can be used at a different backend for you. So online store could be on-prem, SQLite, or you can actually use any supported backend. Local. So here is your provider project, data is local. And if you want to have the GCP, you could say GCP, or if you want to use S3, then you can use S3. So after we have seen our data set, so now what we could do is that we could look into the database and see what is inside those tables. So I will be using this sqlite module in Python, and I will be accessing this feature repo. And you see here that this is our online store. So SQL module will use this connect method to connect this data store, and now we are connecting, and here we will get the table name, and that table name is exactly the table name which we have seen here, that sqlite table is created, and now we can connect to that table and we could print if there is any data. And if you see here, there is no data. If there was any data, we could have printed row here. Now let's use the panda, and you could see here the df, this is your data frame structure, but there is no data. So this is how this constitution of this table look like. Entity key, feature name, value, event ts, and created ts. So timestamp, event timestamp, and created timestamp. So I will wait for data to be added, and now we will look into when that data or when this feature stored value could be added into that. Now we are in feature repo. So why I want to show you that you need to make sure that you are accessing the feature repo, otherwise your code will not work. So here, as you could see here, that we are creating this entity data frame is the data frame which we want to enrich with feature value. So even in our data set, we have so many unique values. For example, if we want to get this unique driver IDs in this given data set, we can actually figure it out. And as you could see here, there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 records. So 5 unique driver IDs are available. However, when we are trying to create the features we want to enrich, we are only selecting 3 records, 1, 2, and 3, and reported satisfaction for 1, 5, and 3. And here is the event timestamp. Now minus the time delta and then different timing. So here is the entity df, feature store, repo path. It means because we are already here, so we are saying that the repo path is local. If you are somewhere else, then you need to pass this whole correct URL. That's how you are going to connect to your feature store. So this object will be correct and ready for you. So connect, here is your store. So now you are connected with your feature store. So this object can be used to make any method call on your feature store. Now you can say, give me the list of entities. Here is your entities. You can actually list those entities. I remember if you have to loop through them because it's just a list. So you need to walk this list one by one. Here, now it comes the historical feature, and that's where you need to understand what are the historical features and what are the online features. Let's come back here, and here you could see there is an offline store and there is an online store. Here is the historical features and here is the online features. So when you are accessing the historical features, it means you are reading the data directly from its source. When you are making a call to get online features, you are getting data directly from your online store, which is part of your feature store. So that's the reason you are making a call to get historical features in entity data frame, which has been defined here for these records, and these are the features. So if we try to do this, will become our training data frame. It means that this data frame which is coming out from stored data, and in this scenario it will be the driver list, that Parquet file. That is our historical data. That's what the source we are using in this example. And these are the entity features which we are selecting from that. So these are the driver IDs which will be pulled only. Now this training DF became a data frame. Let's try to look into the data frame, and here we can look into the data frame. It is a data frame look like. Let's try to, as you could see here, the driver ID 1, 2, 3 are there, and here is the between 1, 3, and 5 the satisfaction is created. So this is a feature created, and here is a cumulative rate for driver each ID, their rate, and then average daily trips. So let's go look into the data set, and here are the trips. So now you can look into depending on each driver. Next, now we have a command with feast is called the materialize incremental. And now we look into what is the feast materialize. So what feast materialize does is that you apply on the offline data store where the data, and you provide the time slice the way you would want to process the data so that it can store the data into the online store depending on whatever feature transformation you would want to perform there. So let's process this materialize incremental at the command line. So we need to set current time, and then we need to call this current time with feast. Then current time is this, and then current time here. From collections, import mapping, and it is materializing one feature views and driver hourly stats. Now when we are here, we can look into the data store now, because it's making a call to get online features. Because at this point, if we look into our SQL data set, make a call, this is the table, and as you could see here, the data is being created in our online feature store or the local sqlite instance. Let's try to get this table records into this data frame format, and this is what you could see that data really look like. Let's close this connection here and come back. Now we are creating this feature vector using the online features. Here are the 3 features for the rows 4 and 5. Let's look into the training data frame. We already see this training data frame. Now if you want to perform the machine learning, here is the, we already use the scikit-learn linear regression, and we are training this model, scoring. Okay, so training, intercept, here is the slope. If you want to predict, here is the prediction. And so what we have done is that in this very quick demo, we have created the features related with our source data set, which has 5 different values, but we have selected only 3 of them to perform this data transformation. And finally, if we want to do the training, we are using these online features, and then we could save this, our model, to the disk. And as you could see here, this driver model is saved at our feature repo folder. So this driver model can be used to perform the to perform the prediction in this next Jupyter Notebook. Here we are using we are importing the modules needed for us, reading this data set, as you can see here. Okay, and this driver order is the data set which I already have in this local machine. As you could see, this is the driver order, so we are using this. And now we are going to feature repo. We are instantiating this feature store object. These are the feature views. So this is list entities, online features, and get the historic features. Okay, so this is, and as you could see here, these are the objects which you need to instantiate, loop through, and get it. Here is our code where we are generating this driver ranking model. It loads the driver model which we have stored in previous Jupyter Notebook. Then feature store, which we are reading from exact same location where we have here. So we just need to make sure it should be in feature repo. and then get online features. It means read all that data from the feature store, and then df, perform the prediction, and then result who the best driver is. So we have started this. Now we are make driver prediction. Here are the list of drivers, and here you could see here among these, and driver 4, he or she is the best driver. And here what I wanted to show you, that you are using the model with this online features. It means this data is being read directly from the record which are related with the data set which we have stored here. And here you could see that these are the different driver IDs who are applicable to this model prediction. So the 5 or 6 different Jupyter Notebook should be helpful for you to understand how the feature store was first initialized, then you applied. It means you make sure that the features definitions you have created, they could be transformed, and then you have also seen that how the registry was created, how your online data store was created, and finally you had ability to either read the data from offline store by calling the get historical features, or the online store which are the transformed result, and you could use that, and then based on that you could perform the machine learning. The Jupyter Notebook used in this video are located at this public code public repo in feature store folder, and here are all the Jupyter Notebooks. The data set are also included here. So if you would want to try the Jupyter Notebooks directly in your Python 3.7, 3.8 or 3.9 environment, I believe that all of these notebooks are going to work as it is. My next step is to, rather than using the sqlite, use the Postgres on local file system to connect with Feast feature store and use as online store. So that would be my next work item, and I will be showing you how I'm using the registry as a local file system, and then the online feature store as the Postgres. That's all, my friends. I hope to see you in my next video. If you have enjoyed our content, please like it, share it, and subscribe it. At last, please be good and do good. Thank you.